All right, ladies and gentlemen, we are starting section 9 or chapter 9, section 9.2. And what is this starting? Is we're going to start talking about logarithmic functions, logarithmic expressions, logarithmic equations, logarithms. All right, so don't feel so oppressed about it or depressed. I know a lot of you guys, I mentioned it in class before we left for break, and I got a lot of gripes and groans. I promise you, this is not bad. You just got to know how it fits into the circle of life, okay? Then there's only one math circle of life, and you guys already know who these people are. So take a look at your screen. It is the order of operations, all right? And I'm not going to go through these with you. You guys already know what they are, but you know parentheses is here. Then there's exponents and multiplication, and yes, division's included inside of multiplication, right? Because multiplication and division are one and the same, right? Division's multiplication is reciprocal. Same thing with addition, okay? So this is the order of operations. So where does logarithms fit into this, okay? So here's a historical facts, okay? Well, what undid addition was subtraction, right? What undoes multiplication? Well, all you guys pretty much know that's division, right? So it has one thing that undoes it, one thing and only one thing, okay? Now, here's a big thing. What undoes exponents? Well, this is where the story gets very, very interesting, because exponents is very, very peculiar. It's because of a property we have taken for granted. We'll talk about the property. Well, as a matter of fact, exponents doesn't just have, but for right now, exponents doesn't just have one inverse, it has two inverses. Okay, so not one thing to undo, it has two. One of the guys we've already talked about in chapter 7, and that was the idea of using roots to undo exponents, right? But then there's this need for logarithms. And this is what we're going to talk about now is logarithms, okay? So logarithms are just another inverse, but an inverse in what form? And that's what we need to talk about, okay? So this is why exponents has two inverses, okay? And I'm going to pose you with a very simple thing. It's this property exponents doesn't have. 2 plus 3 addition is the same as 3 plus 2. Does everybody agree with that? Okay? How about this? 2 times 3 is the same as 3 times 2. Everybody agree with that one? Okay. So now let me ask you the big question. Do you think 2 to the third power is the same as 3 to the second power? No. Clearly this is not true. So this property that's exclusive to multiplication and addition is called commutativity. Okay, and commutativity just means the idea of being able to turn it backwards and forwards, okay? So like subtraction is not commutative. 2 minus 3 is not 3 minus 2, right? So exponents itself, the base property that we've been using, addition, multiplication, and exponents, it's not commutative. And because it's not commutative, depending on what we're solving for or looking for, we might need to use one of the three, okay? So let's break it down. So we're going to call this the holy trinity of exponents, okay? So if it gives me my color palette back, there it goes, it gives it to me. So here we go. We have exponents here, and I'll give you an example of what an exponent is, okay? And you guys have already seen this. And then there's roots, and then there's logs. Now, what I'm going to do is I'm going to tell you what they're used for and how they fit in the ecosystem of things, all right? So in this case, we used exponents to just simplify things, right? And gave us answers, okay? So this is the act of doing exponents. We all know how to do this. This just fell into normal order of operations, arithmetic stuff. Roots, well, roots was the guy, it was used to undo this, okay? So notice we used roots to solve these. Now, but what were we solving for? So the base was missing. Okay, so in exponents, we were just evaluating, getting the answer. Here, we'd be solving for the base. The base would be missing. Well, logs answers the question of, what do we do if the other one was missing? Well, think about it. Well, this first time, we didn't have the answer. The next time, we didn't have the base. Well, logs is used to solve when we have the base, we don't have the exponent, and we have the answer. So we're just looking for the exponent. We need logs to break into that thing. Okay, so this is what logs are. Okay, it's basic. So by definition, Okay, so now you guys understand the whole ecosystem of why exponents need two inverses. All depends on whether or not we're solving for the base, the exponent, or the answer. Okay, and that'll tell you whether or not which one you're doing. So if you have the base and the exponent, that's just like doing normal exponents. We did that already. If you had the base and the answer, but not the exponent, we would need a log to break into this exponent. And then if you had we didn't know the base, we had an exponent, and we had an answer, we could use a root to get down to the base. Okay, so your root, you get down to the base of it, you gotta use the root to get down to the base of it, like a plant, right? Logs, on the other hand, we're gonna use it to get into that exponent. So let's look at the definition. So the best way to give you the definition of how a log fits into things is, maybe I'll just do this. Okay, so we have a base, and I'll write the word base for it. So this is kind of what I did in the air. Exponent also here, an answer, and this just annotates it. Okay, so literally all we're going to do is just a conversion. When we say definition, it's a conversion from log form or logarithmic form to exponential form. Okay, and I'll tell you which one's going which way. So this way would be us converting into log form. Obviously we haven't talked about it yet, and this way would be converting back. Okay, so how does this work into logs? Well, much like we have plus signs for addition and multiplication and division, we have different symbols for those. Well, logs, we don't have a symbol, we have a word. Okay, L-O-G. Okay, the base, so L-O-G. Well, the base that is written as a subscript. Now what you got to get here is this base is the exact same as this base. Okay, and we'll do an example, a concrete example with numbers so you can see it at the end. Okay, the thing we know though, remember, I want you to keep in mind here, before when we were talking about logs, we said, well, we use logs to solve it when we have the base and we have the answer. So now let's look at the answer. Well, if this is the answer is actually written as the log, which is right here on the same line of it. Okay, now we're at a place where we're using different levels of stuff, so you have to be very conscious of how much of like your spatial acuity. Okay, so spatial workout, and if you do that, the more and more you do it, the better your paper will start to look and the better things will start to seem. Okay, so because you won't start thinking things are a base of 2 when it should be a base of 6, kind of a thing. So be careful. All right, and then finally, what's the answer to a log? Well, remember, we're solving for the exponent. So eventually it should help us crack into that exponent. So the answer should be the exponent. So for a concrete example, guys, and this is really all you basically need to really convert logs back and forth. Let's say we had to convert this guy. 2 to the x. Sorry, guys. Convert 2 to the x equals 7 into logarithmic form, log form. Okay, well, here we go. Well, the log is going to be whatever the log is. The base is defined by whatever the base that was used. So in this case, it was 2, so there'll be a base of 2 written as a subscript. Okay, the answer, it would be what it is equal to, which is 7, so that's what would go here. And then finally, this is equal to x. Really that simple. Okay, so just converting it into log form. But notice, this is the whole point. We're now able to solve for x. So that's the big point, is that we can now solve for it in a huge kind of way. All right, now we still need to get some ideas about how to wrap our mind around the numbers. Okay, but this is a basic introduction, and if you could do this, then you can solve different things. Okay, so it's all about how you think about it. So the next time when we come back, we're going to talk about how to evaluate it, and it's all going to pivot on, can we do this? Can we convert back and forth this into that? Okay, so just as a cue, here's one to check for yourself. Do the same thing. It's not now, but I want you to convert this guy, log base 6 of x into 3. Convert that into log form. If you could do that, you're ready to rock and roll. Okay, guys? I'll see you in the next video.